You know, some numbers just feel awkward, don't they? Like 29. It's a prime number, kind of sits there by itself. Well, today, we're going to take that awkwardness and turn it into something really elegant. We're diving into a fascinating mathematical insight that makes checking for divisibility by 29 surprisingly simple and honestly, a little bit of fun. So let's kick things off with a challenge. And yeah, it's the kind of problem that might have you reaching for your phone's calculator, but just stick with me for a minute. I promise there's a more creative way to solve it. Okay, here's our puzzle. Is 1044 divisible by 29? Now, before your brain even starts to think about long division, let's just pause and try to explore a more playful approach. The real secret to cracking this whole thing is all about perspective. Just look at 29. What's it right next to? A much friendlier, rounder number, 30. And that tiny little difference, that single step away, that's our key to everything. Look, of course you can use a calculator. It'll give you the answer in half a second. But this isn't about speed. It's about seeing the creative, kind of playful side of math. We're not here to just memorize a rule. We're here to discover a pattern together. So let's build on this idea. Let's imagine we have a tool, something I like to call the div by 29 machine. It's basically a simple process for taking big numbers and shrinking them way down. And here's the basic idea. You feed a big, kind of clunky number into one end of this machine. It does its thing, and out the other side comes a much smaller, way more manageable number that actually holds the answer we're looking for. Okay, so how does this machine actually work? Well, it's a super simple process. You take your number and you split it in two. The very last digit, we'll call that B. Everything else, the rest of the number, that's A. Then you just calculate A plus 3 times B. And here's the magic. The new number you get has the exact same divisibility by 29. If it's still too big, no problem. You just do it again. All right, time to put it to the test. Let's run our original number, 1044, through the machine for its first pass. So with 1044, our last digit, our B, is 4. That means the rest of the number, our A, is 104. So now we just plug that into our little formula. 104 plus 3 times 4. And that gives us 116. Okay, that's way better than 44, but we can probably go smaller. And the beautiful thing about this strategy is we can just run it through the machine a second time. So round 2. For the number 116, the last digit B is 6. The rest of the number A is 11. Our calculation now becomes 11 plus 3 times 6. And boom, we get 29. Now, is 29 divisible by 29? Of course it is, which means 116 is also divisible by 29, which means our original number, 1044, is a multiple of 29. How cool is that? But this isn't just some clever party trick. It's actually rooted in some truly elegant math. So let's pull back the curtain for a second and see why this actually works. So the key concept here is something called modular arithmetic. I know it sounds a little intimidating, but it's really just a fancy way of talking about remainders. Think of it like a clock. When you go past 12, you just start over at 1. Well, in what we call mod 29, when a number is perfectly divisible by 29, its remainder is 0. So we say it's 0 mod 29. And right here, this is where it all clicks into place. Remember our friendly neighbor, 30? Well, in the world of mod 29, 30 is basically the same as 1. Why? Because when you divide 30 by 29, you get a remainder of 1. This one simple fact is the engine that drives our entire strategy. Now, there's one more crucial piece to this puzzle. It turns out we can multiply our big number by 3, and it won't change whether or not it's divisible by 29. And the reason is that 3 and 29 are relatively prime. They don't share any common factors besides 1. They're kind of from different mathematical families, so they don't interfere with each other's divisibility. Okay, I know this slide looks a little intense, but let's just walk through it together. Any number can be written as 10a plus b, right? Well, when we multiply that by 3, we get 30a plus 3b. And since we just learned that in mod 29, 30 is the same as 1, that 30a effectively just becomes a. And there it is, a plus 3b. And that's it. That's the proof. We've just shown that checking the divisibility of our big, messy number is the exact same problem as checking the divisibility of our small, easy-to-calculate number, a plus 3b. It's just a beautiful, elegant piece of mathematical logic. So, what's the big takeaway here? This isn't really about memorizing a rule for the number 29. It's about a bigger idea, seeing math as a kind of creative playground. And it turns out 29 is a pretty cool number all by itself. It's prime, of course. It's also something called a twin prime because its neighbor, 31, is also prime. And we finally cracked the code of why the number 3 is in our rule. It's the key that unlocks that special relationship with 30 in mod 29. And this, right here, really gets to the heart of it all. Math doesn't have to be about a race to find the fastest answer. Sometimes it's about the joy of the puzzle itself, the creativity of finding a solution, and just having fun playing with numbers. So the next time you are faced with a math problem, just remember that understanding why a solution works can be so much more rewarding than just knowing how to solve it. And it really makes you wonder, doesn't it? What other beautiful, creative solutions are just hiding out there in the world of numbers, waiting for us to find them?